Hello, welcome to lesson 3 for our continuing learning experiment. I hope that lessons 1 and 2 went well. Today for lesson 3, we are going to be doing squares, cubes, and roots. So you're going to need a calculator. You can use your cell phone. I'll show some ways to use the calculator on your cell phone, or if you have a scientific calculator, those are going to be handy, or you can use a calculator on your MacBook. So we are going to go into squares and cubes. So again, just a little recap. In this unit, we've done converting fractions to decimals. Then we did converting decimals to fractions. So those are the opposites of each other, the inverses of one another. And today we are moving on to squares, cubes, and roots. Squares, cubes, and roots. All right, so these topics that we're talking about right now are talking about exponents. So to begin, let's just do a quick review for parts of a power. So power and exponents sometimes kind of get used together to explain this idea. So a power is really the whole thing. So if I was going to write this, the whole part, the big number and the little number up top to the right, is called a power. Sometimes we just get lazy and we call it all an exponent. But inside that power, there are two pieces, so some elements of it. So this piece right here, the big number, is called the base. And the base is the number that gets multiplied. Ooh, gotta squeeze it in there. Got it. So that's the number that gets multiplied. And then, so the base, the big number. And then this little number up top to the right is called the exponent. And the exponent tells us or shows how many times to multiply. So there are a couple of ways of solving, of finding, computing this power. So you could just expand it, regular old calculator world, and do 3 to the 4th, meaning 3 times 3 times 3 times 3. It means the base, the 3 in this situation, and it's going to get multiplied 4 times. If you have a scientific calculator, you are going to look for, so this is my squared button, which is the exponent of 2, but then this caret button is what's showing this expanded multiplication, right? So it's the button we use for exponents that are greater than 2. So I would do 3, and then I'd press this button, and it moves it up to an exponent, and then I would press 4, and enter. So 3 to the 4th power is 81. If you're working on your cell phone, you are going to open up your cell phone app and you will turn it horizontally. And if you see, we have a squared button. So if I was just doing an exponent of 2, we have an exponent of 3, which is a cube. And then this one is our exponent button for more than 2 or 3. So in this circumstance, I'm going to use this button because I want to get an exponent of 4. So I would type 3, and then I'd go over here and press this button. Oop, I pressed the wrong button. 3, and then I would go press my exponent button that is not a 2 or a 3. And then I'd press 4 because I want my exponent to be a 4. And then enter, or equal. Right, so again, this is my squared, this is my cubed, and this is the button that I would use for any other. Don't use this button. We want this guy right here, the XY. And some scientific calculators have this button instead of the caret, instead of this guy right here. And again, you can use cell phone calculator, you can use regular calculator, scientific calculator if you have it, or you could just regular expand it if you don't have a scientific calculator at home. Or you could go online and find a scientific calculator on the internet. So these are parts of the power. So we're going to be using this vocabulary as we're talking about it. So let's talk squares. We're familiar with squares. We've talked about them throughout the school year so far. So squares. And so squaring a number means multiplying that number twice. So squaring a number means to multiply the number twice. And just so that we make sure that we know what we're talking about, 8 squared means to do 8 times 8. I'm taking the base, which is 8, and I'm multiplying it 2 times. And 8 squared is 64. So let's just make a list of our squares. It's really helpful if you just memorize the first 10, the first 12 squares, because then we don't have to spend all that time going back and forth from our calculators. So let's make a list. I'm going to do 1 squared. 1 squared, 1 times 1 is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared, 4 times 4, 16. 5 squared, 5 times 5 is 25. 6 squared, 6 times 6, 36. 7 squared, 7 times 7, 49. 8 squared, 8 times 8 is 64. 9 squared, 9 times 9 is 81. 10 squared, oh, I'm going to have to squeeze to get these in here. 10 times 10 is 100. 11 squared, 11 times 11 is 121. And 12 squared, 12 times 12 is 144. Now, you can, challenge yourself to, oh no, I just drove through those. You can challenge yourself to memorize as much as you want, as high as you want. But if you have this list here, you can then just go back and look at it when you're working on the assignments to help you just go through it really quickly instead of spending time going back and forth with a calculator. So again, squares just means to multiply that number times itself twice. So the opposite, right? We like in math class and algebra to talk about inverses. So squaring means taking that number and figuring out what it is. When we do 4 times 4, we get 16, right? So the squaring is multiplying out. So we are actually going to talk about really quickly the inverse. So squares is our first part. We're going to talk about a square root. Now, a square root is the inverse, which means opposite, of squaring. So we're doing the opposite of squaring when we find the square root. So to find square roots, typically in this unit today, we're going to be just looking at these values down here, the answers to the squareds, and it undoes the number. So taking the square root of a number, taking the square root of 36 means that the answer is 6. So here's my example. So the square root of 36, well, it's 6 because 6 squared is 36. So today, when we're doing square roots, we're only going to be working with these values that are going to be perfectly answered, right? The square root of 16 would be 4. The square root of 25 would be 5. It's going backwards. It's taking the answer of the squared and figuring out what the original problem would be. So if I was going to make a table of square roots, it would be really similar to the table up top. The square root of 1 is 1. The square root of 4 is 2. The square root of 3 is 9. Nope. The square root of 9 is 3. The square root of 16 is 4. Square root of 25 is 5. The square root of 36 is 6. The square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. The square root of 121 would be 11. And the square root of 144 would be 12. So this is our list of square roots, which is the opposite, the inverse of squaring. So we know that squaring and square rooting are inverses. They work backwards from each other, right? If I have the perfect square, 64, I can take the square root of that to get 8. If I had 6 squared, I know that my answer would become 36. So squaring is multiplying by 2. Cubing, so cubing means multiply 3 times. And cubing is a little bit shorter of a list because cubing, you'll notice this with exponents, the bigger your exponent, the larger your exponential value, those numbers get really big, really, really, really fast, right? It starts off, kind of small increments of growing, right? Exponential. But then once we get down here, we're skipping more and more numbers between them, right? So an exponential using an exponent may start out a little bit slow, but then it gets really big, really, really fast. So cubing is multiplying by 3, and the bigger your exponent, so we can expect with cubing these numbers that we get as our answers to be larger, to increase more because we're doing an extra multiplication step. Oh, here comes a cat. Sundance wants to learn about math. So I have 1 cubed, which means 1 times 1 times 1, which is 1. Then I go on to 2 cubed, and 2 times 2 times 2 is 8. And you'll notice we've already gotten bigger. Our squared was 4, but our cubed has already increased. We've gotten to 8. We have 3 cubed, 3 times 3 times 3, which is 27. We have 4 cubed, 4 times 4 times 4, which is 64. And then we have 5 cubed, 5 times 5 times 5, which is 125. And see what I mean by when your exponent gets bigger, right? Up here we only dealt with 2's. Down here we're dealing with an exponent of 3, meaning we're adding one more multiplication into it. And you can tell we're only on 5. Our base is 5 right now, and we're already in the 100s. Whereas up in the squareds, when our exponent was 2, it took quite a while to hit 100. But in our cubes, because we're adding an extra multiplication in, we're getting a larger answer faster because you're doing more multiplication. So cubing is when you multiply the number 3 times. So let's use some deductive reasoning skills. If squaring, and their inverse was square rooting, we have cubing. What do we think that the inverse of cubing would be? Cube root, you're right. So cube root, and this is a little bit different, so I'm going to walk you through how to find this on your calculator. So cube root is the inverse. Remember, inverse means opposite of cubing. So the cube root of 1, now that's the square root. A cube root, we have a little 3 in front of it. And that number right there, it's called an index. And so the cube root of 1, well, if I look up here, I'm going to go backwards, is just 1. The cube root of 8, well, here's my pair. So the cube root of 8 is 2. Now I'm going to show you how to find that on a calculator. So if you have a scientific calculator, so the square root, see right there, it's above the x squared. So if I wanted to do the square root of 64, that green means I have to press the green second button in order for the square root to appear. So I have square root of 64 is 8. Now I want to do the cube root of 8. So if you see right here, this is squared, this was our other exponent. See in the green above it how it has the x in front of it? So in order to find the cube root, I'm going to press 3 because I want a 3 in front of my radical sign, my square root sign. And then I'm going to press the green button because I want to use the green function. And it moves that 3 to the index. So I'm finding the cube root of 8, which is 2. Now on a phone, we are going to turn our phone sideways. And our phone has a square root button. So again, I'd do 64 and then the square root of that, which is 8. And if I wanted to do the cube root, I've got it right here. So I would do 8 is my number inside. It's called a radicand. And then I would press the cube root button, which is 2. If you wanted to do like a 4th root or a 5th root, you're just playing around, it would be the button right next to it. So again, if I wanted to do the 4th root of 81, so I'd do 81, press that button, and then 4, it would be 3. Because 3 to the 4th was 81. So 81, the 4th root of 81 gets us back to 3. We're only focusing on x squared, x cubed, square root, and cube root right now. So let's continue making our pattern. The cube root of 27 would be 3. The cube root of 64 would be 4. And the cube root of 125 would be 5. So these are the numbers that we're mostly going to work with. Sometimes we'll have numbers, the values that are a little bit higher that aren't in our list. And then at that point, that's when you would use your calculator on your phone, a regular calculator, or you could use calculator from the internet on your MacBook. So again, squares, square roots are opposites. Cubes, cube roots are opposites. They're inverses.